curves are all the same, treated the same, act the same, behave the same, with the exception of their blending polynomials. The blending polynomials for these things are different, okay? Which means their 4x4 blending matrix look different, but everything else in the curve is all the same. Okay?
So you're saying just the coefficients, but the actual polynomial, aside from the coefficients, is the same? Like the u?
The u and the v are the same. So now if you have a collection of curves that have been stitched together and kept at a low order, then it's different than having just 4 control points, okay? So we're just talking 16 control points if we're dealing with a surface. If we're dealing with just a curve, a Bezier curve, a B-spline curve, a NURB curve, a Hermite curve, and we go on and on, okay? All the different curves. For 4 points, what is different is going to be the blending function coefficients that go in there are different. Okay? Everything else looks the same. Okay? The book spends quite a bit of time talking about manifold and non-manifold topology. At the heart of a CAD system is what? What's at the very heart of a CAD system? The graphics kernel. So at the heart of a CAD system is a graphics kernel, and that graphics kernel is either a manifold kernel or a non-manifold kernel, or today we're seeing kind of a blurring of manifold and non-manifold. And so you're seeing that the kernels are beginning to support both manifold and non-manifold topology. Okay? But they were very different approaches. They came out of different dissertations or theses or whatever. This little simple block, okay, if it has a line that comes out the side of it, that's dangling out there in air, and you're able to get the block as a solid, and this line is just kind of hanging out there, but it's part of the block, then you are working with a non-manifold kernel. If you have a surface that's kind of attached to the block, and the surface is just kind of floating, it doesn't have kind of mass on either side of it, okay? It's just floating there, but when you click on it, and it highlights not only the block, but this dangling face, okay? You again are dealing with a non-manifold kernel, okay? Those kernels, while they're really great for kind of modeling and creating geometry, they are very difficult to deal with when trying to get mass properties, trying to get engineering data out of it. It sits there and says, I'm not sure how to take this edge, this line, or this surface, this plane, and try and make mass kind of correspond to it. Okay? So typically the mechanical engineering kind of CAD systems don't like to support non-manifold geometry. If you're doing 3D Studio Max, any of you have ever played with 3D Studio Max? Can you generate dangling edges and faces and have them attached to objects? You can. I don't know whether you do, but you can, and it doesn't really care about it. Why? Because all it's really doing is chasing after a good-looking image, a picture, okay? So here's another way that you can end up with a non-manifold object, is by having two objects and basically saying, I want the intersection of these two objects And you get this little dangling set of faces, or set of edges in this view. It's actually a surface. And you get this kind of closed volume. Most CAD systems that are doing mechanical work, mechanical engineering work, will throw an error. And it'll say non-manifold geometry. It may show you this because it can represent it, because the kernel has the capability of doing it. So it may show you that, but it's not going to let you go on until you fix it. How would you fix something like this? If you wanted to do the intersection, how would you fix it? You'd either push them in further to each other, or you'd pull them out just slightly, giving a gap. And if you pulled them out slightly, you would end up just with the bottom part of this. You wouldn't end up with the two edges up in the top. So being able to work in the CAD system and deal with manifold, non-manifold kind of things, the chapter does a good job of kind of describing these problems and how to deal with them. We'll pick up there a week from today.
Yeah, I got a whole I may have to stop my